Have you ever wondered how a star is born and dies? It all begins in a nebula, a celestial nursery if you will, where the magic of star formation takes place. A nebula isn't just a pretty space cloud. It's a bustling hub of gas and dust, swirling and dancing in the vast void of the cosmos. Now let's imagine this nebula as a cosmic soup. The ingredients? Hydrogen and helium with a dash of heavier elements. The heat? Gravity. That's right, gravitational forces cause these elements to coalesce, to come together, creating a center of mass. As this mass grows, the pressure and temperature at its core rise, leading to the formation of a protostar. This is the embryonic stage of a star, where it's still gaining mass and growing. And so, a star begins its life, not with a bang, but with a mere whisper in the cosmos. This is the stellar beginning, the dawn of a new light in the universe. The star, now a fiery young entity, enters what we call the main sequence. This isn't just a phase, it's the longest stage of a star's life. Here, the star finds balance. It's in a state of hydrostatic equilibrium where gravity pulling inward is exactly balanced by pressure pushing outward. And what gives the star its brilliant shine during this time? It's all about the process of nuclear fusion. In the heart of the star, intense heat and pressure fuse hydrogen atoms together to form helium. This fusion releases a tremendous amount of energy, radiating outwards from the star's core and causing it to shine brightly. It's like a cosmic dance, a constant balancing act between gravity and pressure. This process of burning hydrogen into helium can continue for billions of years, depending on the size of the star. In this stable phase, our star could remain for billions of years, a beacon in the night sky. But all things must change, and so too does our star. It swells, cools, and reddens, becoming a red giant. As the star exhausts its hydrogen fuel, the core contracts and the temperature rises. This high temperature ignites a new fuel, helium. This helium-burning phase signals the onset of the red giant phase. Now our star is experiencing a cosmic makeover. It's like it's going through its own stellar midlife crisis. As helium burns, it causes the outer layers of the star to expand dramatically, becoming hundreds of times its original size. As these outer layers expand, they also cool down. This cooling is what gives the star its distinctive red hue. It's a phase of transformation, a time of change and growth. The star, once a compact, steady-burning ball of hydrogen, has now become an enormous, pulsating sphere of helium fire. Our star, once a pinpoint of light, has now grown into a colossal, fiery globe. The end approaches. Our star, once a fiery beacon of light and energy, now faces its inevitable demise. This final act, this closure, is as varied and as dramatic as the stars themselves, depending on the star's initial mass. Let's consider a star like our Sun, categorized as a small to medium-sized star. After burning through its hydrogen fuel, it expands into a red giant, then starts to shed its outer layers. This stellar wind, a slow process spanning thousands of years, creates a beautiful formation known as a planetary nebula. What remains is the star's core, now a white dwarf, so dense that a teaspoon of its matter would weigh as much as an elephant on Earth. This once vibrant star now begins a slow fade into obscurity over billions of years, its light gradually dimming until it eventually becomes a black dwarf, a cold, dark remnant of its former self. In contrast, large stars meet a more spectacular fate. Once the nuclear fuel is exhausted, the core collapses under its own immense gravity, triggering a cataclysmic explosion known as a supernova. This explosion is so bright that it can outshine an entire galaxy, albeit briefly. The remnants of this explosion can result in either a neutron star or, if the star was massive enough, a black hole. A neutron star is incredibly dense. A sugar cube-sized piece of this star would weigh as much as a mountain. A black hole, on the other hand, is a region of space where gravity is so strong that nothing, not even light, can escape its grasp. From a whisper in the cosmos to a brilliant flash of light, such is the life of a star, a cycle of birth, life, and death played out across billions of years. And so we have journeyed through the life of a star. From its fiery birth in a nebula, we watched as it matured into the stable phase of the main sequence. We bore witness to its transformation into a red giant, and finally, its explosive death, scattering its elements throughout the cosmos. This cycle of birth, life, death, and rebirth is the rhythm of the universe. A star's life may seem incomprehensibly vast and complex, but it's all just a part of the grand dance of the cosmos.